In the second use case, we'll have what is called a real-time operating system running on the Cortex M3 based platform. This real-time operating system is the one allowed to modify the default setting of the Cortex M3, allowing the user-based thread or program to run in thread unprivileged and use the process stack pointer instead of the main stack pointer. So the init sequence to modify this default setting of the Cortex M3 after reset actually is part of the real-time operating system software. After reset or power on reset of the Cortex M3 microprocessor, the system will boot in thread, privilege, execution state, and will use the main stack pointer. This is we have seen already in previous slide. So the RTOS will trigger the first jump to each scheduler or software running in handler mode. Then it will modify the bit number 0 and bit number 1 of the control register. Because the software is running in handler mode, which run always in privilege state, the software is allowed actually to access the control register. After modifying the bit 0 and bit 1 of the control register, and then exiting the interrupt service routine, we'll jump back to thread mode. However, thread mode will execute now in unprivileged and will use the process stack pointer instead of the main stack pointer. And why that? Because we have already modified the bit 0 and bit 1 of the control register in handler mode. The user-based application and thread will run always in thread mode unprivileged execution state and you use the process stack pointer, while the real-time operating system scheduler will run always in handler mode and will execute always in privilege and use the main stack pointer. This helps, and as we can see, to create this isolation between the RTOS code, which is our trusted application that has the right or the privilege to access the full or all critical hardware resources of the Cortex M3 microprocessor, and the user-based application which we don't trust and must not have access to this critical hardware resources. So this is why this one is running always in privilege and the user application is running in unprivileged execution state. We'll have multiple threads here, not single one, but all of them, they must run on thread unprivileged and use the process stack area. Of course, each thread will have its own stack context, but all of those contexts are part of the process stack area. So we must not have a collision in terms of stack area between the process stack area and the main stack area. Again, to keep this isolation between our trusted application, the RTOS system, and untrusted programs, which are the user-based threads.